say, where'd my glasses go? All right, so we are going to be measuring some things today. So true or false? Ray AB names a ray with endpoints A and B. True or false? False. Why is it false? Rays only have one endpoint. So the one that's false is B is not the endpoint. Number two, you name a ray by its endpoint and another point on the ray. True or false? True. So that's your idea. So we're going to look at angle. An angle is formed by two rays and the same endpoint. That should be on the flashcard. So here you've got, in question 3 and 4, two rays and they share an endpoint. That endpoint is called a vertex. So this right here is a vertex. And then ray AB and ray BC, this is a side of the angle. So the rays make up the side. The B makes up what's called that vertex, the endpoint. So you are to name the rays that form each angle. So number 3, you have ray and must start with B and go through A. So that's 1. And ray BC. So the rays on these ones are exactly the same, aren't they? No? Why? Very good. So we've got our vertex here is B, but our vertex here is A. So be really careful. You've got ray AB and ray AC. So they have the same points. And by the way, when we name the angle, angles are always named with 3 letters. The vertex is in the middle of that. The only time that we can name an angle without 3 letters is if perhaps they have like a little 1 in here, then I can name the angle 1. But when I name this angle here, it's going to look like this. Angle, and I would put a little less than sign with an arc through it because sometimes it looks like an L, right? So I definitely would put an arc through there. So angle ABC, or you can name it angle CBA. There are 2 ways that I could name this angle. And if I had the 1 in there, we could also name it or angle 1. But only if the 1's in there. You can't put the 1 in there and name it 1. There's no other way to name this angle. Those are the only 3 ways. Name this angle, please. So Bailey, what's one name?
BAC.
BAC is correct. And Mariah, what's another one? BAC. A has to be in the middle because it's your vertex. CAB. So your goal when naming angles is that that vertex has to be in the middle. So when I look at the name of an angle, I can tell by just looking at the middle what its vertex is. So it's really like the endpoint. It's the vertex. All right, so we have this. We have the size of the vertex and how to name it. So we've talked about all of this. You cannot be really, really careful. You cannot name it by its vertex necessarily. I don't like that one. Now your book may allow it. And here's why. Here's why I don't like that. Technically you could name this angle A, but what if I had another angle right here going through point D? If you named this angle, angle 1 here, if you named it angle A, do I know which angle you're talking about? No. So if the angle is by itself, alone, with nothing else touching it, then technically I guess you could name it angle A. I don't teach it that way. I think it's a bad habit to get into. Mostly because when you get in this situation, then you tend to call it angle A. and you're going to get it wrong because I don't know which is angle A in this situation. So be super careful when you name it by the vertex. I would avoid that. So there's your number, that's what we're talking about there. So that would be angle 1. And a point on each ray in the vertex, that would be your angle BAC and your angle CAB. Questions on naming an angle? Easy pick, right? All right. Oh, they want you to take this angle right here, BAC, so let's go ahead and redraw that. So, BAC. So name the vertex. What would that be? The vertex would be A, right? So the 2 points that are not the vertex are your B and C. Name the sides. They've already put the ray notation above it. So your sides are ray AB and ray AC. Can those go in any other order? Nope. Name the angle 3 ways by its vertex. Well, you know, I don't like that. Not my favorite. Not my favorite. But they want you to put angle A. The only reason why you can do that is it's a standalone angle. And we already did this on the other side, so angle BAC and angle CAB. And then by the number of the angle. So on number 9 and 10, I want you to do that on your own. Number 9, cross out the ray that is not a ray of angle KML, and you can just look at the notation KML. You don't even have to have a picture for that. You can tell what's the vertex and what are the rays just by looking at the notation. And then on number 10, circle all the possible names of angle KML. So you got 1 minute. So which one did you cross out on 9? The middle one, right? Okay, J isn't even on that angle. And I'm going to talk about why each of these are not the right one. I think for 1 and 2 you can figure that one out. But look at angle JKL. If you follow that with your fingers, JKL, does it even make an angle? No. So that can't be. J and K, follow with your fingers. J to M to K. That's not angle 2, is it? So that can't be it. Follow this one, J to M to L. Well, that includes angle 2, but it includes too much. It includes both angle 1 and 2, so that can't be it. K and J, is that correct? Nope. And L and K. L and K, is that correct? Yes. So there's only 2. Does that make sense? Then you're going to draw your own example of each type of angle. Okay, so we've got acute, right, obtuse, and straight. So an acute angle is from 0 to how many degrees? Remember? Acute means acute. Well, if you think of something that's so acute, something that's acute, what do you think of it as? Things that are acute are small, they're little. I've never been accused of being acute. I'm a good person. so acute is between 0 and 90 degrees. It is an acute angle does not include a 0-degree angle, it does not include a 90-degree angle. So this would be an example of an acute angle. And when you give an example, I want you to give the degree measure. So let's just say that this is 40 degrees. So it's clear that you're telling me, no, it's in between that 0 and 90. A right angle means that it is exactly how many degrees? 90. And so a right angle looks like a corner, a straight corner. You can depict that 90 degrees with a little square, like this. That's how I would prefer it. Rather than putting 90 degrees in there, you need to get used to that square notation. Obtuse sounds like obese, which means big, right? So that means that x has to be less than some number but greater than another number. So angles that are obtuse are less than how many degrees? 180 degrees, but greater than 90. This is read backwards on this left side. 180 degrees is a straight angle, by the way. This is 180 degrees. So this is 90. 90 plus another 90 would make a straight angle. So an obtuse angle might look like this. You want it wide open. And again, I want you to put an angle measure in there to make it quite clear. Like for instance, if this is 130 degrees. But quite clear that you're telling me that you know that that angle is between 90 and 180. And then a straight angle is 180 degrees, and so that is just a straight line. I'm going to put a point right there. So those are your 4 types of angles. If you're not familiar with them from middle school, and or we can do a lot of them in algebra, but you should be familiar with those. Put them on a flashcard and learn them. So now we have this diagram over here. It gives you some information about the diagram. If they were not written in here, we would write them in there. It says the measure of angle ABC, so trace ABC with your finger is 70 degrees. So they put this arc mark in there, which is an angle measure, and they said that that's 70 degrees. The measure of angle BFE, so trace from B to F to E, they said it's 90 degrees. So notice that they put both a square in there and the 90 degrees. They're covering the bases. Describe each angle as acute, right, obtuse, or straight, and give an angle measure to support your description. So angle ABC. So from A to B to C. You should know that. 70 degrees, right? So is that acute, obtuse, right, or straight? So that's acute. And then it is 70 degrees because that's a given. Then angle CBD. Trace it with your fingers from C to B to D. What's the degree of that angle? 110. How do I know it's 110? These 2 angles right here create a straight line. So that means that the measure of this angle plus the measure of this angle adds up to 180 degrees. So if I know that that's 70, this is 180 minus 70, which is 110 degrees. So if that's 110 degrees, then I know that that has to be an obtuse angle. So I'm going to use my knowledge that a straight line adds up to 180 degrees. You have to be able to see it, and this is where your spatial reasoning comes into play. Then for CFG, from C to F to G. So now we're all the way down here. What's the angle that's next to it? 90. Don't these 2 make a straight angle also? So if this one's 90, isn't this one what? 90 as well. And so I know that this is 90 degrees. So that angle is straight. Oh no, sorry. Wrong. How about right? And that's 90 degrees as well. And last they have CFH from C all the way to F to H. C to F to H. What kind of an angle is that? Yeah, it's a straight line, so it's 180 degrees, right? So we've got straight equals 180 degrees. In your homework tonight, you must draw the diagram. When I graded your homework this weekend, about 50% of you drew the pictures, 50% did not. I will not continue to give you credit if you don't draw the pictures that go with the problem. Questions on that? So that should be fairly simple. Then we've got our protractor. So we're going to write the measure of each angle. Oh, I guess they put it in there for you. You don't need our protractor. You realize that if you take a protractor onto your book, it may not read the same? Why? Well, the book may end up reducing something from its original. On my protractor, this would read about, what, 35 degrees? And on their protractor, oh, it's actually the same. Shocking but true. I wouldn't go and measure in the book, because it may or may not, when they blow it up or reduce it, it may not come out to be the same. Depends on how you get it. All right, so LKH, trace it with your fingers. From L to K to H. Now, from here to here is where they're asking you to measure. Wouldn't this, that phone needs to be turned off, wouldn't this right here be the adjacent angle that makes a straight angle to it? What's the measure from, because this is where the 0 is over here. This is your 0 degrees here. From here to here, what does that measure? 145. So what's left out of 180 for this one? 35 degrees. That would be 180 minus 1, you said it was 45? Okay. So that's where our 35 degrees comes from. So HKN, from H to K to N. Well, what's that? Yeah. From H to K to N, that's a straight angle. So this one is straight. I put it in the wrong spot. And this is 180 degrees. This one, is this one obtuse, acute, or right? This is acute. And then MKH, from M to K to H. So we're looking at it from here to here. So again, they didn't give me an angle that started at 0. So I want to look at this angle here. From here to here, what angle is that? Or how many degrees? No, look at the right one. It's from 0 to 0. Well, I guess you could have gone backwards, huh? Yeah, you could have gone backwards because they're showing you the double scale. From here is 35, right? So this one is 145. And that's 145. That makes that obtuse. Then they give me a picture. Looks like synchronized swimming. ABC is 49 degrees. So they put little angles in there. ABC. Oh, here it's ABC. So that angle there is 45 degrees. 49. What is the measure of DEF? Notice that all of these two right here have single arc marks, and those have double. So DEF doesn't that have single arc marks also? They're telling you that that's 49 degrees also. So if ABC has a single arc mark, the other angle with the same number of marks is angle DEF. The measure of angle ABC and the measure of angle in exercise 18, so I want to tell you what the answers are equal or congruent, in other words. And then that means that it is 49 degrees. So then we come to a postulate, which should be a flashcard. Angle addition postulate, what does that sound like? The segment addition postulate, it's the same theory. Choose smaller angles, add to give you a larger angle. This one says if point B is in the interior of AOC. So let's add some marks to this. O is the vertex of the angle, so that means O is going to go right here. And then A and C have to be on the side, so I'm going to put A here, and I'm going to put C here. They said that B is in the interior, so B just has to be somewhere in here. Doesn't have to be directly in the middle, it could be anywhere in between the two sets. I choose to put it out here, so I'm going to put a dashed line through B. It says then that the measure of angle AOB, so A to O to B is right here, plus the measure of angle BOC, so from B to O to C, I'm going to put double arc marks here, is equal to the overall big angle AOC. The two small angles add up to the bigger. I expect you to draw a picture to represent these problems so that you can see the equation to solve. So, we're not going to do this part, because I did cross that part out. We matched it along with this one. All right, so then flip it, last page. Let's look at an actual example where we have justifications. They told you that DEF is a straight angle. What do you conclude from the fact that DEF is a straight angle? What's your conclusion? It adds up to 180 degrees, not obtuse, it's a straight angle, right? It adds up to 180 degrees. What are the measures of angle DEC and angle CEF? So here's your justification. Measure of angle DEF is equal to 180 degrees. Wouldn't that be the definition of a straight angle? We made that conclusion that from that straight angle we got the fact that it's equal to 180 degrees. Then what are they doing here? Small angle plus small angle equals 180 degrees. This plus this equals 180. How do I know that the two smaller add up to 180 degrees? What's the postulate on the other side say? Angle addition postulate. So this is your angle addition postulate. The two smaller angles added up to the larger. Then what are they doing from here? They're substituting. So then this is substitution. And then aren't they simplifying from here to here? They took 11x and they added 2x to it and they got 13x. Then they took negative 12 and they added 10 to it and they got negative 2. So that is your simplifying. Then what do they